Determine the values of x where the function f is discontinuous. At each number where f is discontinuous, state the conditions for continuity that are violated. We know the definition of continuity. For a function f to be continuous at x, we have to have limit of the function when x approaches to a. This is limit value that should exist and should be equal to the function value at a. If this is true, then we say the function f is continuous at a. Limits should exist, the function value should also exist, and function value at a should be equal to the limit of the function when x approaches to a. This is also called limit value of f at a. This is function value. So if we look at this graph carefully, then here comes, there's a hole, okay, and jumps to this point at -2. When x equals -2, the exact value is there. This is the function value. But when we find the limit, when x approaches to 2 from left or right, we are here. That means the limit value is 1. So the limit value is 1, but the function value at -2 is 3. So the function is discontinuous. So I'm going to write f is not continuous or discontinuous at x equals -2. Why? Because the limit value when x approaches to -2 from either left or right, we get 1, but the function value dot is at 3. Okay, as limit value, limit of the function when x approaches to -2, or you can just write limit value is not equal to the function value at -2. In fact, the function value is 3 and limit value is -1. That's the first point where the function is discontinuous. And if we move along, because always we move from left to right, at -1, look at the jump. There is a hole, there is a hole. In fact, the function is not even defined at -1. Left hand limit, when we approach -1 from left hand limit, we are here, that 3. So x equals, at x equals -1, the function is discontinuous. Now there are a couple of things. Limit does not exist. Left hand limit is 3, right hand limit is less than 1. Okay, since left hand limit of the function when x approaches to -1 from left hand limit is not equal to right hand limit, or in short we can say the limit does not exist. Since limit of the function when x approaches to -1, limit does not exist, so it's already discontinuous. Moreover, the function is not defined at -1 because we don't have dot. Also, the function at exactly -1, f at -1 is undefined. Okay, there are 2 violations, but 1 would be enough for a function not to be continuous. And if we move along, here is 1. What happens here is when we approach 1 from right or left, the function increases without bound. So the limit does not exist. Okay, since limit of the function when x approaches to 1 does not exist, and at the same time x equals 1 is a vertical asymptote and there is no function value. Also, function at 1 is undefined. Okay, if you want to know the names of these 3 types of discontinuities, this is called removable. At -2, this is removable. We can just move redefine dot over here, and the discontinuity is gone. This is jump, because from the left side we are here, from the right side we are here. This is called jump discontinuity, and this is called infinite discontinuity because the function becomes infinity.